Dear students, in this session shall discuss about tsunami. The term tsunami is actually a Japanese word meaning coastal wave and was little known before December 2004, although the phenomenon is as old as earthquakes. In fact, is related to earthquakes in its origin because it is caused by severe earthquakes, generally of magnitude greater than 6.5 on Richter scale, that occur in the ocean floors and cause vertical displacement in the oceanic crust. Those earthquakes that often cause horizontal displacement do not produce tsunamis. A tsunami appears and causes tide like effects, but it is not caused by gravitational attraction of the moon or the sun as tides. Similarly, a tsunami creates large waves in the oceans like winds, which have crests and troughs. Wave period, wavelength, and wave height. But waves generated during tsunamis are many times longer and larger, having wavelengths measured in hundreds of meters and wave period for many minutes, even up to an hour. This, when compared with wind waves, already described that have a maximum wave height of 5 to 7 meter, wavelength of a few meters, and wave periods measured in seconds at the best up to 5 minutes appear great. The tsunami waves rise up to heights of 20 to 30 meter with ferocious velocities of more than 500 km per hour, washing coastal inlands up to a distance of 1.5 to 2 km away from the sea shore. Near the shore, the tsunamis often reach as bores, tall vertical walls of seawater of enormous volume that, on breaking, are capable of uprooting trees, washing away buildings, tossing ships, animals, and human beings with the residing waters to far off depths in the oceans. Occurrence. Although tsunamis are not of rare occurrence in deeper regions of Pacific Ocean, they are of very rare occurrence in most of the coastal countries or countries having vast coastlines like India. It is an established fact that the tsunami of December 2004 witnessed in southern India, Indonesia, Philippines, Ceylon, and Sumatra was the first such event recorded in Indian history for last many centuries. The December 2004 tsunami was caused by a major vertical displacement of oceanic crust that was focused near Sumatra in Indian Ocean. The Sumatra tsunami took over 2 hours time to reach Tamil Nadu coastal zone. It caused tremendous loss to life and property in Indonesia, Philippines, Thailand, and India. The casualty figures given below are more mere indicators and in no way actual measure of catastrophic cost. Engineering considerations. Since tsunamis are sub-oceanic seismic events like earthquakes on the earth, these are neither preventable nor predictable. However, with a great deal of research having been done in the field of seismology throughout the world, there are well defined codes of practice available to design and construct shock resistant construction to withstand massive damage during an earthquake. No such codes of practice are yet available for designing tsunami resistant offshore or onshore structure for two reasons. Tsunamis have been and still remain least studied natural phenomena due to their rare occurrence in the coastal regions of most of the countries. Second one, the magnitude of seawater waves arising during such occasions is often so enormous that forces generated due to breaking of such waves could hardly be analyzed even theoretically to attempt tsunami resistant construction for any purpose. The present global strategy to face risks from tsunamis is therefore focused on developing dependable warning system so that the population along coastal regions can be pre-informed and evacuated well in time before the onslaught of the ferocious tsunami waves. A lot of work is presently being done in this direction by the researchers located in the coastal countries. Some of the likely effects of tsunami on construction and desirable design solutions as depend as the deemed necessary as determined by government of India are outlined like likely effect flooding of lower floors, action of hydrostatic forces such as pressure on walls by variation in water depth on opposite sides, effects of uplift forces caused by buoyancy during flooding. Solution: raise the building above flood level and design for static water pressure on walls. Second likely effect is slope failure due to saturation and or loss of bearing capacity. Solution for this is avoid slopes getting unstable on flooding. Second solution, evaluate bearing capacity and sharing strength of soil under conditions of saturation. Third likely effect, hydrodynamic forces that are likely to push front faces of the building and may also cause drag effect. Solution for this is the building should be firmly anchored to foundation and additional design strength imparted against water forces. Fourth likely effect is debris impact and soar that can arise during onrush of wash waves and wave recession. Solution for this effect is the first solution is to design buildings at higher elevations and also introduce additional strength for impact loads. Deeper foundations are necessary against shore besides shore protection treatment around them. For all these designs to be effective, the design engineers are required to make a thorough study of the area with regards to its distance from the sea, its elevation above mean sea level, assumed wave heights of a probable tsunami generated views. Thank you.